Okay, so in your notes you have examples of each of these things. And I think what I'll do in the remaining time is I'll pick one example that you didn't talk about in your groups and just show it to you to expand your horizons. And maybe one example that you did talk about so that we could dig a little bit into the details about how it would actually be done. So I am going to start by talking about lawns. Nobody mentioned lawns except with respect to irrigation. And that's because ecologists don't like lawns. We think they're really bad. But of course, things are not good or bad from a scientific perspective. They're just there. So what do lawns actually do? Well, they serve functions or ecosystem services that people care about, like recreation. And when it comes to running around on turf, that can take a lot of wear and tear. Lawns are pretty good. But we know they have costs and benefits. So they obviously have a big water cost. Postdoc in my lab just published a study where she calculated the evapotranspiration of Los Angeles, 70% of which comes from lawns. So indeed, the water cost is high. But are lawns made up of C3 or C4 species? It's a trick question, because there are both. Some turf is made up of C4, and some turf is made up of C3. And some weeds are made up of C4, and some weeds in lawns are made up of C3. So it means you could have a wide range of carbon isotope values. Whenever you see that C3 and C4 question popping up, we always know that carbon isotopes can tell us lots of cool stuff. So let's take a look at the carbon isotope ratio of lawns across the United States. Now, you already know lots of stuff about C4 plants and their distribution and why they have a different isotope ratio than C3 plants. So a question that came up in a research project I was associated with was, is the distribution of C4 grasses in lawns across the United States the same as in natural grasslands? So do C4 lawns follow the rules that C4 plants and natural ecosystems follow for how they're distributed? And so this is a beautiful application of isotopes, because instead of sitting there with a big pile of lawn clippings and pulling out leaves from one species that might be C4 or one species that might be C3, which is really, really difficult to do, all you have to do is homogenize your lawn clippings and measure its isotope ratio. And you know the proportion of C3 versus C4 species. There's actually no better way to do it. And so you can do that with lawns all over the country, which Tara did, and found that in fact, lawn isotope ratio is related to the proportion of C4 plant cover, as it should be, and was able to look at the distribution of C4 grasses all over the country. And it turns out that the distribution of C4 grasses all over the country in lawns doesn't quite follow expected climate trends. It turns out that in some cities, like here in Salt Lake City, our lawns are all C3. You very rarely find C4 plants in Salt Lake City lawns, even though the summers here is really hot. And there are native C4 plants in this region, and we think the reason is a behavioral reason. It is because C4 plants don't look very good in the shoulder seasons. In the early spring and in the late fall, they turn brown. And people probably don't like that. And so I personally think, and this Jim may disagree, that that's why C3 lawns they're much more prevalent here than in most of the other cities that we sample, because C3 lawns can thrive, and they look great in the spring and in late fall. And some other cities, like Los Angeles, are the reverse. There's way more C4 turf than you might expect, and it's because in the climate of Los Angeles, which is very mild, it's C4 lawns that look really nice for a much longer period in the year than C3. And so people are overriding the climate constraint on C3 and C4, we think. So that's the isotopes giving us a hint, but you need to do a little bit more follow-up into human behavior and preferences and what different nurseries are selling, what species nurseries are selling in the area to figure out the mechanism. And also it turns out that if you do this in lawns that are heated up, you find out that lawns that are warmed, and some people who are crazy like me actually do artificial warming experiments on lawns to simulate both global warming and the urban heat island effect. And it turns out that you will see isotopic enrichment in warmed lawns because the C4 weeds do better when it's warm. And those really horrible weeds that people hate, like crabgrass, are C4, and that's why they're horrible, because their physiology allows them to outcompete C3 plants under the right temperature conditions. And so in an experiment where heat was applied to certain patches of lawn, the weeds just went kind of crazy. So it turns out in a warmer world, we will have more weeds. And so people might spray more pesticides and so forth. So fun stuff with C3 and C4 grasses. There's always fun stuff to do with C3 and C4 grasses. Any questions or comments about lawns? Yes? You can use the ceramic heaters that they use in reptile terrariums, and you can buy them at the pet store, and they're super cheap. Yeah. Okay, so the crabgrass invasion, I'm going to skip over this for the interest of time. I know you guys are going to start flipping through your things here. So let's go to the last slide before pollution impacts, which are some data from Lache, who is here in the room. And this is just a point that I want to make this, after many years of experience, but I still don't understand why this happens. If you're in a city and you're sampling most ecological parameters on a spatial basis, so you've got distributed sampling over a range of neighborhoods, a range of different parcels, and you will end up sampling in people's yards or neighborhoods that have different socio-demographics, right? Richer people, poorer people, and so forth. You almost always find a relationship between whatever you're sampling and income. And I see this for almost every parameter we look at. And sometimes we can't explain the correlation. These data are leaves, delta 15N of leaves, and you haven't done nitrogen isotopes in detail yet. And nitrogen isotopes are a little bit crazy, but delta 15N of leaves versus the income of different, basically neighborhoods where these leaves were sampled, and they're related. And you'll find this with biodiversity, and you'll find this with biomass, and you'll find this with lots and lots of variables. And we don't always understand the correlation. And I would say we still don't understand this correlation. It's basically Lache's entire dissertation, and she would be happy to expound, I'm sure, at length about it. But just something to think about. When you're sampling spatially in cities, money makes the world go round, and in ecology, we don't understand all of those mechanisms, and there's lots of theories. So a little tidbit for you for the future. Comments about that? We could take a few minutes and speculate what drives this relationship, if you wish.
Whose work is this?
Lache's.
Oh, okay, so, sorry. You just kept like doing this, and I was trying to figure out who I needed to talk to.
You definitely need to talk to Lache. Any ideas?
What are your theories, Lache?
Yeah.
Lache. So I think that it is a pollution story because it's more enriched in the lower-income neighborhoods. And based on the grasses, we know that they're unfertilized, and so I don't think it's a fertilization story. And I have like 3 more chapters trying to figure that out.
So it may be that poor neighborhoods experience more nitrogen pollution. There could be various reasons for that. That could be one explanation.